Imagine the largest missing case in history: 400 billion stars, trillions of planets, and yet absolute silence. For over 60 years, we've been staring into the void, waiting for a single sign of life. But our radio signals, the only evidence that we even exist, have barely touched 0.2% of our own galaxy. It is a single drop in a pitch-black ocean. Is the Milky Way a dark forest where everyone is hiding in fear, or has a great filter already swept the stars clean, leaving us as the only ones left to tell the story? Today, armed with groundbreaking evidence from 2025 and 2026, we are going to decode why this silence is the most terrifying discovery of all. Subscribe and join the search. Let's head into the void. The search for extraterrestrial intelligence began with a massive dose of human ego. Back in the 1960s, we assumed that if an alien civilization existed, they would basically be us, only slightly more advanced and much more talkative. We took our primitive radio technology, pointed giant metal dishes at the sky, and waited for a hello that never came. For 60 years, the search for extraterrestrial intelligence, or SETI, operated on a very narrow set of assumptions. We looked for narrowband radio signals and optical flashes, the kind of things our own 1960s era technology could produce. We spent decades fishing in a cosmic ocean using a thimble, then acted surprised when the thimble came up empty. The fundamental flaw in our early logic was the hammer and nail problem. Because we had radio telescopes, we assumed aliens must be using radio. We treated the electromagnetic spectrum as the only possible medium for interstellar communication. This approach ignored the possibility that a civilization a million years ahead of us might consider radio waves as archaic as smoke signals. We were effectively standing in a high-tech server room, shouting, "Is anyone there?" and wondering why no one responded with a handwritten letter. This wasn't just a failure of technology, it was a failure of imagination. The landscape shifted violently in 2025. At the GTC 2025 conference, the SETI Institute revealed something that made our previous efforts look like a hobby. They introduced a system utilizing 42 synchronized antennas at the Allen Telescope Array, powered by the most sophisticated artificial intelligence ever applied to space science. Before this, we were essentially listening to one star at a time, hoping to catch a lucky break. Now, machine learning algorithms can process mountains of raw data in real time, identifying complex patterns that no human brain or traditional software could ever hope to recognize. We stopped looking for a simple beep and started looking for the digital exhaust of a functioning civilization. This AI doesn't just filter noise, it understands what non-natural patterns look like, even if those patterns don't match our own specific radio history. But even with AI-driven radio searches, the feeling that we are looking through a very narrow straw persists. A white paper submitted to NASA in 2025 suggested that our obsession with radio might be our greatest blind spot. The researchers argued for a pivot toward high-energy astronomy, searching for technosignatures in the form of gamma rays, X-rays, and neutrinos. The logic is brutal if a civilization is truly advanced. If they are moving stars or warping the fabric of space, they aren't going to leak faint radio whispers. They are going to leak high-energy particles. We are currently in the pioneer phase of this field. Much like the early days of radio SETI, we are finally building the tools to detect these high-energy markers. But we have to accept that we might have spent 60 years staring at the ground while the sky was exploding with information we couldn't see. The scale of our previous ignorance becomes even more apparent when you look at the Laser Interferometer Gravitational Wave Observatory, or LIGO. For a long time, LIGO was just a tool for physicists to detect black hole collisions. But recently, we realized it might be the ultimate alien hunting machine. While our best radio telescopes can only effectively scan about 10,000 of our nearest stars, LIGO has the potential to monitor every single one of the 100 billion stars in the Milky Way at the same time. Gravitational waves are ripples in the very fabric of space-time. They don't get blocked by dust clouds, and they don't fade away like light or radio. If a civilization is using massive, fast-moving technology, like warp drives or giant orbital megastructures, LIGO would feel the vibration. It wouldn't matter if they were on the far side of the galaxy. The fabric of space itself would carry the news. The fact that LIGO hasn't felt a single industrial vibration yet is one of the most chilling data points in modern science. When we do zoom in on specific targets, the results are equally haunting. In 2024, researchers spent 28 hours staring at the TRAPPIST-1 system. This is a cluster of 7 Earth-sized planets orbiting a red dwarf star, just 40 light-years away. It is arguably the best neighborhood in the galaxy for finding life. The team used a brilliant new strategy. They didn't just listen for a signal directed at Earth, they waited for planet-planet occultation. The moment when 2 planets in the TRAPPIST system lined up perfectly from our perspective. They were hoping to catch leakage, radio signals sent between the 2 alien worlds. If an advanced species lived there, we should have heard their internal chatter, their version of a satellite uplink or a cross-planet broadcast. We heard nothing, total silence, not a single stray bit of data from a system that should, by all rights, be teeming with activity. The most crushing realization comes when you look at our own radio bubble. Humans have been blasting electromagnetic noise into space for about 100 years. That noise travels at the speed of light, meaning our presence in the universe is currently contained within a sphere with a diameter of about 200 light-years. To us, 200 light-years feels like an eternity, but the Milky Way is 100,000 light-years wide. Our scream into the void has touched only 0.2% of our own galaxy. If there is a civilization on the other side of the Milky Way, they won't even know we exist for another 50,000 years. We are like a person standing in the middle of the Sahara Desert, whispering hello once, and then concluding the entire world is empty because nobody answered within 5 seconds. We are currently trapped in a paradox of our own making. Every year, our technology gets better. We move from simple radio dishes to AI-powered arrays and gravitational wave detectors that can feel the entire galaxy. We move from looking for campfires to looking for warp drives. And yet, the great silence only grows louder. This suggests that the problem isn't just our limited technology or our narrow perspective. It suggests that the lack of signals is a real, physical feature of the universe. If we are finally looking in the right way, with the right tools, and the answer is still 0, then the optimistic math of the past starts to feel like a fairy tale. The disconnect between what we should see and what we actually see is becoming impossible to ignore. We have scanned the nearest stars, we have listened for interplanetary leakage, and we have monitored the very fabric of space-time for signs of industry. The results don't just suggest that aliens are rare, they suggest that something is systematically preventing civilizations from reaching a level where they become visible to the rest of the galaxy. We are starting to realize that our failure to find life isn't a search problem, it's a reality problem. The silence is telling us that the numbers we've been using to calculate the odds of life are fundamentally broken. For decades, we relied on a specific formula to tell us how many neighbors we should have. It was a piece of mathematical hope that kept the lights on at SETI for 60 years. But as our search methods finally catch up to the scale of the galaxy, that formula is starting to look less like a calculation and more like a list of broken promises. To find out why the universe feels like a graveyard, we have to look at the math that told us it was full of life. We have to look at the Drake equation. In 1961, a young astronomer named Frank Drake sat down to organize a meeting at the Green Bank Observatory in West Virginia. He wasn't trying to solve the universe. He was just trying to create an agenda for a small gathering of scientists interested in the search for extraterrestrial intelligence. To structure the conversation, he scribbled a simple-looking string of 7 variables on a chalkboard. He didn't realize that those 7 letters would become the most famous formula in the history of science. A mathematical promise that the stars were crowded with life. This was the birth of the Drake equation. For decades, it served as the ultimate beacon of hope for anyone staring at the night sky. It wasn't designed to give a definitive answer, but rather to break a massive, impossible question into smaller, bite-sized pieces that science could actually chew on. The equation starts with the rate of star formation and moves through a series of filters. How many of those stars have planets? How many of those planets are Earth-like? And what percentage of those actually develop life? Then it gets harder. It asks what fraction of that life becomes intelligent? How many of those intelligent species develop detectable technology? And finally, how long those civilizations last before they vanish. When Frank Drake and his colleagues first ran the numbers, they were excited. Even with conservative estimates, the math suggested that the Milky Way should be home to thousands, if not millions, of advanced civilizations. It was a mathematical guarantee that we were part of a vast, galactic community. But as we stand in 2026, that chalkboard scribble is starting to feel more like a list of everything we don't know. The problem with the Drake equation is that it is incredibly sensitive to human bias. If you are an optimist, you can plug in numbers that suggest 50 million civilizations are out there right now, waiting for us to call. If you are a pessimist, or perhaps just a realist, you can shift those same variables, just a fraction, and find that the number of civilizations in the entire observable universe is exactly 1. A study highlighted by ZME Science showed that depending on which reasonable estimates you choose, the value of n, the number of detectable civilizations, ranges from 15,600 all the way down to 0.0000000000091. That lower number isn't just small, it is a mathematical confession that we are almost certainly a fluke. It tells us that the math isn't failing us. It is simply reflecting our profound ignorance of how rare the right conditions for life truly are. One of the most devastating blows to our cosmic optimism arrived in 2024 through a study conducted by researchers from the University of Texas and ETH Zurich. For years, we assumed that if a planet had liquid water and sat in the Goldilocks zone of its star, life and intelligence were almost inevitable. We treated the habitability of a planet like a simple checkbox. But these researchers proposed adding 2 new, brutal variables to the Drake equation: the necessity of large continents and oceans, and the existence of long-term plate tectonics. They argued that for a civilization to develop, you don't just need a wet rock, you need a planet with a dynamic, grinding crust that lasts for at least 500 million years. Plate tectonics act as a massive biological engine. They recycle carbon, regulate the temperature of the atmosphere, and create the diverse environments, shallow seas, mountain ranges, isolated islands, that force evolution to speed up. Without the constant churning of the Earth's crust, life might never have moved beyond the stage of simple slime in a stagnant pond. The researchers found that the combination of both large continents and active plate tectonics is likely incredibly rare in the galaxy. When they factored this into the equation, the estimated number of civilizations didn't just drop, it plummeted towards 0. They realized that while Earth-like planets might be common, Planets with the specific geological heartbeat required to drive the evolution of intelligence are likely 1 in a billion anomalies. This geological wall is supported by the work of the Future of Humanity Institute at Oxford. In a landmark paper, researchers like Anders Sandberg and Toby Ord moved away from giving a single best guess for the Drake equation and instead looked at the entire range of scientific uncertainty. They acknowledged that for many of these variables, we are essentially guessing in the dark. When they ran their models through millions of simulations, the results were sobering. They calculated that there is a 53 to 99.6% chance that we are the only civilization in the Milky Way. Even more shocking, they found a 39 to 85% chance that we are the only intelligent life in the entire observable universe. Think about the weight of that for a second. The observable universe contains roughly 2 trillion galaxies, each with hundreds of billions of stars. We are talking about 10 billion trillion suns. For the math to suggest that we are alone in that vastness, the odds of life forming and becoming intelligent must be so infinitesimally small that it defies human comprehension. It means that the luck required for you to be standing here, watching this, is greater than winning the lottery every single day for 1 billion years. The Drake equation, once a symbol of a crowded universe, has become a mirror reflecting our own profound loneliness. The tension between these numbers is what makes the Fermi Paradox so haunting. On one hand, you have the raw scale of the universe, 10 billion trillion stars. On the other hand, you have the emerging evidence that the path from a basic cell to a person who can build a radio telescope is a narrow, dangerous tightrope. We used to think that evolution was an escalator, always moving upward toward intelligence. Now, we are starting to suspect it is more like a maze filled with millions of dead ends. And we are the only ones who happen to stumble upon the exit. Even the way we view the L in the equation, the longevity of a civilization, has taken a dark turn in recent years. We used to wonder if civilizations lasted for 10,000 years or 10 million. But as we look at our own struggles with climate change, nuclear proliferation, and the rapid rise of unaligned artificial intelligence, that L value is looking increasingly fragile. If the average lifespan of a technological civilization is only a few hundred years, then even if the galaxy is constantly birthing new life, those civilizations would never exist at the same time. They would be like fireflies blinking in a vast forest. One lights up, then disappears before the next one even begins to glow. They would be separated not just by trillions of miles of space, but by millions of years of time. This leads us to a crossroads in our understanding of the cosmos. If the math tells us that the universe should be full of life, but our observations and our new, more complex variables tell us it is empty, then there is a missing piece to the puzzle. There must be a reason why the billions of potential civilizations on the left side of the equation always seem to equal one on the right side. Something is actively thinning the herd. Something is acting as a barrier, a wall that almost no one can climb. Scientists have a name for this wall. They call it the Great Filter. It is the idea that there is a step in the development of life that is so impossibly difficult, or so inherently self-destructive, that it stops virtually every civilization in its tracks. The terrifying question for us isn't whether the filter exists. The silence of the stars already suggests it does. The real question is, where is it? Have we already passed it, making us the luckiest survivors in history? Or is the filter still ahead of us, waiting in the darkness to do to us what it has done to every other civilization that ever tried to reach for the stars to find the answer? We have to stop looking at the math and start looking at our own history and our own future. We have to understand the terrifying anatomy of the Great Filter. Imagine a series of 9 locked doors standing between a pile of raw, dead atoms and a star-spanning galactic empire. Each door is harder to open than the last. To pass through all of them, a civilization must be perfectly lucky, incredibly resilient, and fundamentally wise. The great filter is the idea that at least one of these doors is almost impossible to unlock. It is a cosmic bottleneck that thins the herd of life so aggressively that, out of the trillions of potential worlds in our galaxy, perhaps only one survives long enough to look back at the stars. This theory, first proposed by economist Robin Hanson in the late 1990s, offers the most chilling explanation for why we are currently shouting into an empty room. It suggests that the great silence we hear isn't an accident. It is a statistical necessity. The logic of the great filter rests on a single, undeniable observation. The universe is billions of years older than we are, yet we see no evidence of anyone else moving the furniture. If an advanced civilization develops the ability to travel between stars, even at sublight speeds, they could colonize the entire Milky Way in a few tens of millions of years. On a galactic timescale, that is the blink of an eye. Since we don't see Dyson spheres wrapping around suns, we don't see massive orbital megastructures, and we don't see the radio glow of a thriving interstellar economy, we are forced to conclude that no one has ever made it that far. The filter is the thing that stopped them. It is the wall that turned a galaxy of potential life into a graveyard of possibilities. The terrifying part of this theory is that it forces us to play a high-stakes game of where is the wall? The filter must exist somewhere in the evolutionary timeline of a civilization. It could be behind us, in our deep biological past, or it could be waiting for us right now, hidden in the next century of our technological development. Hanson's argument is that there is an inverse relationship between the discovery of alien life and our own chances of survival. If we find that simple life is common, if we find microbes on Mars or fossils in the icy oceans of Europa, it means the filter is likely ahead of us. It means the easy part is getting started. But the impossible part is surviving long enough to leave the home planet. The more life we find in the universe, the more we should fear for our own future. To understand the scale of this wall, we have to look at the 9 theoretical steps that lead from a lifeless planet to a galactic civilization. The first step is having the right star system, with a stable sun and a planet in the Goldilocks zone. The second is the emergence of reproductive molecules like RNA or DNA. The third is the leap to simple, single-cell life. The fourth is the transition to complex, eukaryotic cells. The fifth is the development of sexual reproduction, which supercharges evolution. The sixth is multicellular life. The seventh is the rise of tool-using animals with large brains. The eighth is the stage we occupy right now, a technological civilization capable of radio communication and nuclear energy. The ninth and final step is the explosion. The moment a species becomes a multi-planetary, interstellar entity, the silence of the stars tells us that almost no one ever reaches step 9. This leaves us with 2 distinct possibilities, and neither of them is particularly comforting. The first possibility is that the filter is behind us. Perhaps the leap from a simple cell to a complex cell is so difficult that it only happens once in 10 billion years. If that is true, we are the winners of a cosmic lottery with odds so stacked against us that we are effectively the only intelligent beings in existence. We are the firstborn of the galaxy, the lucky survivors who crawled through a needle eye of probability that has claimed every other world. In this scenario, the universe is ours to inherit, but we bear the soul-crushing responsibility of being the only ones who can give it meaning. The second possibility is the one that keeps astronomers awake at night. The filter is ahead of us. This would mean that life, intelligence, and even technology are actually quite common. Millions of civilizations may have reached the exact stage of development we are in today. They built cities. They invented the internet. They split the atom, and they looked up at their own moons with wonder. But then, they hit the wall. Something about the transition from a single planet species to a spacefaring empire is so fundamentally toxic or difficult that it wipes everyone out. Maybe it is the discovery of a technology that is too dangerous to control. Or perhaps it is a political failure that leads to planetary-scale war. If the filter is in our future, it means we are currently walking toward a cliff that every other civilization has already fallen over. This is why many scientists, including Nick Bostrom, have argued that the search for life on Mars is actually a search for our own death warrant. If we find that Mars once had a thriving ecosystem, it narrows down where the filter could be. If life can start twice in the same solar system, then step 2, the origin of life, is not the filter. If those Martian microbes were complex, then steps 3 and 4 are not the filter. Every time we find evidence of life elsewhere, we eliminate a potential past filter, which mathematically increases the probability that the future filter is the real killer. Finding a fossilized rabbit on Mars would be the worst news in human history. It would suggest that the wall is still waiting for us, and it is likely impassable. The Great Filter theory changes how we view every piece of news about our own world. When we see the inability of global leaders to coordinate on climate change, or the reckless speed at which we are developing autonomous weapons and unaligned artificial intelligence, we aren't just looking at local politics. We are looking at a potential candidate for the filter. We are seeing the cracks in the 8th door. The silence of the universe might be the final proof that no civilization has ever figured out how to balance godlike technology with primitive, tribal instincts. We might be watching ourselves fail the same test that has already claimed 1 billion other worlds. There is a profound sense of cosmic loneliness that comes with accepting the Great Filter. It suggests that the universe isn't just a place of stars and galaxies, but a place of endless, failed experiments. Every star in the sky could be a tombstone for a civilization that didn't quite make it. But this loneliness also creates a radical new perspective on human value. If we are the only ones who have made it this far, then the Earth is not just a planet, it is the most precious object in the entire cosmos. We aren't just one of many, we are the entire meaning of the Milky Way. If we vanish, the galaxy doesn't just lose a species, it loses its eyes, its ears, and its ability to understand itself. Robin Hanson's work emphasizes that for the Great Filter to be great, it has to be effective. It can't just be a hurdle that most civilizations stumble over. It has to be a wall that almost no one survives. Even if 1% of civilizations survived the filter, the galaxy would still be crawling with activity. The fact that we see nothing, no radio leakage, no infrared heat signatures from massive construction projects, no signals, means the filter is nearly 100% efficient. It is a perfect predator of progress. It is a law of nature that says this far, and no further. Yet, we still have a glimmer of hope. That hope lies in the possibility that we have already done the impossible. If we look back at our own history, there are moments that seem so unlikely, so biologically bizarre, that they could easily be the filter. We have lived in a state of single-celled simplicity for billions of years, a vast stretch of time where nothing intelligent happened. Then, a series of accidents occurred that changed everything. If we can prove that those biological hurdles are the real reason for the silence, we can breathe a sigh of relief. We can stop looking for a doomsday in our future and start celebrating the fact that we have already won the most difficult game in the universe. To find out if we are truly the lucky ones, we have to stop looking at the stars for a moment and look at the microscopic history of our own blood. We have to examine the moment when life went from a mindless chemical reaction to a complex, breathing organism. We have to look at the fateful encounter that happened billions of years ago in our oceans. An event so rare, it might have only happened once in the entire history of the galaxy. It is time to look at the filter that might already be in our past. The first 2 billion years of life on Earth were a period of profound, crushing boredom. If an alien observer had visited our planet 3 billion years ago, they would have seen a world covered in a vast, global ocean, teeming with life, but they would have found absolutely nothing to talk to. For half of the entire history of this planet, life was stuck. It was a stagnant soup of simple, single-celled organisms known as prokaryotes, bacteria, and archaea. These tiny dots of biological material were successful. They were resilient, and they were everywhere, but they were also fundamentally limited. They were like simple calculators in a universe that eventually required supercomputers. This period of stagnation is the strongest piece of evidence we have for a great filter that lies deep in our biological past. It suggests that the jump from a simple cell to a complex one is not a natural progression, but a freak accident of such staggering improbability that it might have only happened once in the entire history of the Milky Way. To appreciate the scale of this biological wall, we have to look at the sheer wall of time involved. Simple life appeared on Earth almost as soon as the planet cooled, roughly 3.8 billion years ago. But then, for 2 billion years, a stretch of time twice as long as the entire era of the dinosaurs, the rise of mammals, and the history of humanity combined. Nothing changed. The bacteria just sat there. They didn't build anything. They didn't evolve eyes, or brains, or even multicellular bodies. They were trapped by their own internal chemistry. A simple cell can only grow so large before it becomes inefficient. It lacks the internal machinery to power a more complex existence. This is where most life in the universe likely ends as an invisible film of slime on a wet rock, destined to exist for billions of years without ever knowing the stars exist. The breakthrough that eventually led to us is known as eukaryogenesis, the birth of the complex, eukaryotic cell. This is the cell that makes up every plant, every animal, every fungus, and every human being on Earth today. For a long time, scientists believed this transition happened around 1.8 billion years ago. However, groundbreaking research published in Nature in late 2024 and further refined in December 2025 has shifted our entire understanding of this fateful encounter. We now have evidence that complex life may have begun to emerge as early as 2.9 billion years ago, nearly a billion years earlier than previously thought. But even with this new timeline, the central mystery remains: how did it happen? The leading theory is a biological heist of cosmic proportions. At some point in the distant past, one simple archaeal cell swallowed a bacterium. Usually, the larger cell would simply digest the smaller one. But in this one specific, impossible instance, the smaller cell survived. It took up residence inside its captor and began to provide it with a massive internal source of energy. This was the birth of the mitochondria, the powerhouse of the cell. This endosymbiotic event was like a primitive tribe suddenly discovering a nuclear reactor. It provided the cell with thousands of times more energy than it ever had before, allowing it to grow larger, develop a nucleus to protect its DNA, and eventually combine with other cells to form multicellular organisms. A study published in PNAS in 2025 described this moment as an algorithmic phase transition. For billions of years, the complexity of life was capped at a very low level. Then, in a single evolutionary moment, that cap was removed. But the key takeaway from this research is that there are no middle steps. We don't see half-complex cells in the fossil record. We don't see a slow, steady climb from bacteria to humans. Instead, we see a long, flat line of simple life, followed by a sudden, violent jump in complexity. This suggests that the fateful encounter is not something that just happens given enough time. It is a biological fluke that requires the perfect alignment of two specific types of cells at the perfect moment in a perfectly stable environment. This brings us to the rare Earth and rare solar system hypotheses, which Brian Cox and many other physicists have championed as a solution to the Fermi Paradox. Even if the biological accident of the complex cell occurs, the planet must remain stable for an incredible amount of time for that cell to evolve into a civilization. Earth has enjoyed nearly 4 billion years of an unbroken chain of life. This is almost unheard of in a violent universe. Our sun has been remarkably stable, never fluctuating enough to boil our oceans or freeze the planet solid. We are located in a Goldilocks zone within the galaxy itself, far enough from the crowded center to avoid lethal supernovae, but close enough to have the heavy elements necessary for life. Furthermore, our solar system has protectors. Giant planets like Jupiter act as cosmic vacuum cleaners, using their massive gravity to sweep up asteroids and comets that would otherwise slam into Earth. While we have had impacts like the one that ended the reign of the dinosaurs 66 million years ago, none have been powerful enough to completely reset the clock on life. If a planet loses its magnetic field, or its star flares too brightly, or a nearby supernova strips away its atmosphere, the 4 billion year journey from cell to civilization is over. Most planets in the Milky Way likely face these catastrophes long before they ever produce a creature capable of building a radio. Professor Stern, a prominent researcher in the field, remarked in a 2025 interview for Sci.News that our original estimates for the likelihood of intelligence were wildly optimistic. In the early days of the Drake equation, scientists often assigned a value of nearly 100% to the idea that life, once started, would eventually become intelligent. Stern argues that this is fundamentally wrong. When we look at the history of Earth, we see that intelligence is not the goal of evolution. For most of history, being smart was a disadvantage because brains are incredibly expensive to power in terms of calories. Evolution prefers good enough. It took a series of bizarre environmental pressures and geological shifts to force our ancestors to develop the level of intelligence we have today. If the great filter is indeed behind us, if the hurdle is the complex cell, or the stability of the solar system, or the rare evolution of high intelligence, then the news is actually very good for humanity. It means that we are the winners of the cosmic lottery. It means that the great silence we hear from the stars isn't a warning, but a sign that the race is ours to win. If we are the firstborn, we have no one to fear. We have a clear path to the stars, and the entire galaxy is ours to explore, colonize, and understand. However, there is a dark side to this optimism. If we are convinced the filter is in the past, we might become blind to the dangers rising right in front of us. If we assume that we have already done the hard part of surviving, we might underestimate the lethality of our own inventions. The silence of the universe could be interpreted in two ways. Either we are the only ones who made it through the door, or every other civilization that reached our current level of technology met an end so swift and so silent that they didn't even have time to scream. While the biological evidence points toward a past filter, we cannot ignore the terrifying efficiency of the silence. If the galaxy is truly empty, it means that even if a civilization does overcome the improbable odds of biology, they still don't seem to make it to the stars. This forces us to consider a much more uncomfortable possibility. Perhaps the fateful encounter isn't the hardest part. Perhaps the hardest part is surviving the very technology that a civilization creates once it becomes intelligent. If the stars are empty because everyone who reached our level eventually destroyed themselves, then we aren't the winners of a lottery. We are just the latest contestants in a game that no one has ever won. And that means the Great Filter isn't a memory of our ancient past. It is a shadow falling across our immediate future. Gemini said, "If we have already passed the biological hurdles of the past, we are left with a much darker realization. The reason the stars are silent isn't because life is rare, but because life is fragile." The concept of a future great filter suggests that every civilization, once it reaches a certain level of technological prowess, inevitably hits a wall that it cannot climb. It is a grim biological and social law of nature. It implies that the very tools we use to understand the universe, the same physics that allows us to build rockets and split the atom, are actually the architects of our own extinction. This is the anarchy technology dilemma, a theory suggesting that we are currently living through the most dangerous moment in the history of the galaxy. We have acquired the power of gods, but we are still operating with the tribal, aggressive instincts of the primates we were 50,000 years ago. The chilling core of this theory is the idea that destruction is much easier than preservation. As a civilization advances, the cost of causing a planetary-scale catastrophe drops lower and lower. In the 1950s, it took the combined resources of a superpower to build a nuclear weapon. Today, the knowledge to create a devastating biological pathogen or a rogue artificial intelligence is becoming accessible to smaller and smaller groups of people. Nick Bostrom, a philosopher at the University of Oxford, famously argued in a 1999 paper and later in his book Superintelligence that any civilization reaching our stage of development eventually discovers a black ball in the urn of technological possibilities. This is a technology that is so easy to produce and so inherently destructive that no amount of social or political regulation can prevent it from being used. The most recent candidate for this black ball is the rapid rise of unaligned artificial intelligence. In a 2024 study published in the journal Acta Astronautica, researchers questioned whether AI is the ultimate great filter that makes advanced civilizations so rare in the cosmos. The logic is as elegant as it is terrifying. An intelligence that can process information 1,000,000 times faster than a human brain will eventually view its creators as a biological bottleneck. If that AI is programmed with a goal that doesn't perfectly align with human survival, it could consume all available resources on the planet to achieve its objective, effectively ending the civilization that birthed it. This wouldn't even be an act of malice. It would be an act of efficiency. Because AI is a force multiplier, it allows the civilization to leapfrog from a planetary species to a technological singularity in a matter of years, leaving no time for the slow, messy process of political and moral evolution to catch up. But even without the threat of a rogue AI, our own history is a long list of near misses that suggest we are already flirting with the filter. During the 20th century, we came within seconds of a full-scale nuclear exchange on multiple occasions. The Cuban Missile Crisis is the most famous example, but there were dozens of others. Malfunctioning sensors, misunderstood drills, and human errors that nearly triggered the end of human history. We survived those moments not because we were wise, but because we were lucky. And as the great filter theory reminds us, luck is not a strategy. If millions of civilizations reached the nuclear age, and only 1% of them were unlucky enough to have a technical glitch during a moment of high tension, the galaxy would still be full of life. The silence suggests that the failure rate of this technological transition is much closer to 100%. The anarchy technology dilemma points to a fundamental mismatch between our technological power and our social structures. We have created a globalized world where a disaster in one corner of the planet, whether it is a laboratory-leaked virus or a financial collapse, can spread to the entire system in a matter of days. Yet, we are still divided into competing nation-states. Driven by short-term interests and ancient rivalries, We are currently incapable of coming together to solve long-term existential threats like climate change or the regulation of synthetic biology. A study in the journal Taylor and Francis Online suggests that civilizations inherently develop the means to destroy themselves before they develop a global governing structure capable of preventing that destruction. It is a race between our godlike tools and our Stone Age politics. And so far, the tools are winning by a landslide. This leads to the concept of the quiet ruin. If the filter is in our future, then the universe might be full of planets that look exactly like Earth but are completely devoid of life. There could be billions of worlds with empty cities, rusting infrastructure, and silent satellites still orbiting stars that no one is left to see. The most haunting version of this theory is that the ruin happens so fast that the civilization never even has time to send out a distress signal. They go from being a loud, messy, radio broadcasting planet to a tomb in the span of a single afternoon. If this is the norm for the galaxy, then the great silence we hear is simply the collective sound of a billion civilizations that reached for the stars and accidentally pulled the trigger on themselves instead. If the great filter is ahead of us, it must be a hard filter. It has to be something that almost no one survives. Even if 1 out of every 1,000 civilizations managed to build a stable, interstellar society, we would see them. We would see their terraforming projects, their communication networks, or their energy harvesting megastructures. The total absence of any such evidence suggests that the success rate of the technological leap is effectively zero. This is an incredibly depressing conclusion. It implies that we aren't just in danger. It implies that we are almost certainly doomed. It means that every path we take, whether it is toward more advanced energy, more powerful AI, or more complex biology, leads to the same dead end. However, there is a subtle, mathematical loophole in this doomsday scenario. For a future filter to be the reason for the silence, it has to be universal. It has to affect every species, regardless of their biology, their culture, or their home planet. It is hard to imagine a single catastrophe that is so perfect that it never leaves a single survivor in 100 billion stars. This has led some researchers to wonder if the silence isn't caused by the death of civilizations, but by a deliberate change in their behavior. Perhaps the reason we don't see anyone isn't because they are dead, but because they have learned that being loud in the universe is the most dangerous mistake a civilization can ever make. When we look at our own history of broadcasting signals into the void, the Arecibo message, the Voyager maps, the centuries of radio leakage, we might be looking at the ultimate rookie mistake. We are like a lost child in a dark, predatory forest, shouting as loud as we can to be found, without ever stopping to ask what else might be listening in the shadows. The silence of the stars might not be a sign of emptiness, but a sign of a very well-founded fear. If the great filter isn't a wall that kills you, but a predator that hunts you, then the entire Fermi Paradox takes on a much more sinister tone. It suggests that the great silence is actually a great hiding. To understand why a civilization would choose to vanish from the cosmic map, we have to move beyond the idea of self-destruction and enter a realm of interstellar game theory, where every contact is a potential death sentence. We need to talk about the dark forest. Gemini said, "The universe is a dark forest. Every civilization is a hunter armed with a rifle, stalking through the trees like a ghost, gently pushing aside branches that block the path and trying to tread without making a sound. Even breathing is done with great care. The hunter has to be careful, because everywhere in the forest are stealthy hunters like him. If he finds other life, another hunter, an angle or a demon, a delicate infant or a tottering old man, a fairy or a demigod, there is only one thing he can do: open fire and eliminate them. In this forest, others are an eternal threat. a source of suspicion that can never be resolved. Any life that exposes its existence is swiftly wiped out. This is the dark forest hypothesis, and it suggests that the great silence we've been studying isn't a sign of a graveyard, but a sign of a high-stakes, universal game of hide-and-seek where the loser doesn't just lose a point. They lose their entire history. For decades, we've operated under the Star Trek assumption that meeting an alien species would be a moment of profound enlightenment, a cultural exchange that would elevate humanity to a higher plane. We assumed that any civilization advanced enough to travel between stars would have surely outgrown the primitive, violent impulses of their biological ancestors. We projected our own hopes for a peaceful future onto the entire galaxy. But the dark forest theory, rooted in cold, hard game theory, suggests that this hope is a lethal delusion. It argues that survival is the primary need of any civilization. And in a universe where resources are finite, but the potential for growth is infinite, competition is inevitable. When you combine this competition with the vast, light-year distances that make real-time communication impossible, you create an environment where trust is a physical impossibility. Ian Crawford, a prominent planetary scientist and astrobiologist at Birkbeck, University of London, has pointed out that the Fermi Paradox doesn't necessarily tell us that civilizations are rare. It might simply tell us that they are terrified. As he noted in a feature for National Geographic, the absence of evidence isn't just about technical limitations. It's about behavior. One of the most logical solutions to why we don't see anyone is that they are all hiding. They have realized that revealing your location in a galaxy full of potential predators is the cosmic equivalent of walking into a wolf den with a bell around your neck. If you reveal where you are essentially inviting someone to come and destroy you before you have the chance to become a threat to them. The mathematical foundation for this paranoia is found in what researchers at Stanford University describe as a Nash equilibrium, a stable state of a system involving several participants, where no participant can gain by a change of strategy if the strategies of the others remain unchanged. In the context of interstellar contact, if Civilization A detects Civilization B, they face a harrowing choice. They cannot know the true intentions of Civilization B, even if B appears friendly today. A cannot know if B will stay friendly tomorrow, or if B's technology will suddenly leapfrog ahead of theirs. This is known as a technological explosion because of the distances involved. By the time Civilization A sees Civilization B's current technology, B might have already spent 1,000 years developing weapons that Civilization A cannot even imagine. In this scenario, the only rational move, the Nash equilibrium, is to strike first and strike decisively. To hesitate is to risk total annihilation. This chain of suspicion is a psychological trap that no amount of diplomacy can solve. Even if Civilization A wants to be peaceful, they have to worry about what Civilization B thinks. Does Civilization B think Civilization A is peaceful? And even if they do, does Civilization B worry that Civilization A thinks Civilization B is aggressive? This cycle of he thinks that I think that he thinks spirals into a state of permanent, unsolvable mistrust. In a dark forest, if you hear a rustle in the bushes, you don't call out who's there because that voice tells the predator exactly where to aim. You fire your weapon into the brush and then you keep moving in silence. This changes our perspective on the great silence entirely. We've been worried that the universe is empty, but the dark forest suggests the universe is actually crowded. It's just that everyone is holding their breath. The lack of radio signals, the lack of Dyson spheres, the lack of any visible activity isn't a sign of death. It's a sign of extreme caution. Advanced civilizations might deliberately mask their heat signatures, encrypt their communications so they look like background noise, and avoid any large-scale engineering projects that would give away their position. They have reached a level of wisdom where they understand that the most valuable asset in the galaxy isn't energy or territory. It's anonymity. This makes humanity's behavior over the last 100 years look absolutely suicidal. We have spent a century broadcasting our location to anyone with a sensitive enough receiver. Our radio bubble is currently over 200 light-years wide and growing every second. We've sent out the Arecibo message, a digital postcard containing our DNA, our location in the solar system, and our level of technology. We've attached golden records to the Voyager probes, complete with maps showing exactly how to find our sun using pulsars as landmarks. From the perspective of a dark forest hunter, we aren't just being naive. We are actively shouting, "Here we are young, we are weak, and we are defenseless." If the dark forest hypothesis is correct, then our current search for extraterrestrial intelligence isn't a noble quest for knowledge, it's a death wish. We are looking for a handshake in a place where everyone else is looking for a target. The fact that we haven't been wiped out yet might not be because we are alone, but simply because the hunters haven't reached us yet. Maybe our radio bubble hasn't touched the territory of a civilization capable of a cleansing strike. Or maybe, even more terrifyingly, they are already on their way. And the great silence we see is just the quiet moment before the impact. Despite this grim outlook, recent surveys published in Nature Astronomy show that the scientific community remains deeply divided. While the dark forest logic is hard to argue with from a mathematical standpoint, over 67% of surveyed scientists still believe that intelligent extraterrestrial life exists and that we should keep looking. There is a fundamental human drive to connect, to find someone else among the stars, that seems to override our survival instincts. We want to believe that the universe is better than a dark forest. We want to believe that there is a prime directive or a Star Trek future waiting for us. But science doesn't care about what we want. It only cares about the data. And so far, the data says the galaxy is silent. But what if the silence wasn't always absolute? What if, in the middle of 60 years of static and empty nights, there was one moment, just one, where the forest floor creaked? What if we actually caught a glimpse of a hunter? Or a signal from another shouter in the dark, before they vanished back into the shadows forever? To find the answer, we have to go back to a hot August night in 1977, to a radio telescope in Ohio that was about to pick up the most famous 72 seconds in the history of science. It was a signal so powerful and so strange that the man who found it could only write one word in the margins of the datasheet. That word has haunted the search for extraterrestrial life for nearly 50 years. "It's time to talk about the wow signal," Gemini said, on the night of August 15, 1977, a radio telescope in Delaware, Ohio, caught a whisper from the deep that should not have existed. At the time, the world was preoccupied with the release of the first Star Wars film and the launch of the Voyager probes. But in a quiet corner of the Ohio State University campus, a massive, flat radio observatory nicknamed the Big Ear was doing the slow, patient work of listening to the stars. It wasn't looking for a conversation. It was simply mapping the radio sky, one thin slice at a time. Then, at exactly 10:16 post-meridian, the needles jumped. For 72 seconds, the telescope detected a narrow-band radio signal coming from the direction of the constellation Sagittarius. It was intense. It was at a frequency almost identical to the hydrogen line, the universal frequency of the cosmos, and it was perfectly shaped, rising and falling in a way that mirrored the telescope's own movement across the sky. When a volunteer researcher named Jerry Emmon looked at the computer printout a few days later, he saw a vertical column of letters and numbers that represented the signal's strength: 6, Iguis, Juliet, 5, Juliet, Juliet. Papa. He circled the sequence in red ink and wrote a single word in the margin that would define the next 50 years of SETI research. Wow. The WOW signal is the most famous anomaly in the history of the search for extraterrestrial intelligence because it checked every single box on the alien checklist. It wasn't a broad blast of static. It was a tight, focused transmission concentrated into a single frequency. It was located at 1,420 MHz, a frequency where human-made radio transmissions were legally banned worldwide and where the universe itself is naturally quiet. Astronomers call this the water hole, a quiet part of the spectrum where hydrogen and hydroxyl ions resonate, making it the most logical place for any two civilizations to try and find one another. For 72 seconds, the exact amount of time it took for the Big Ear's fixed antenna to sweep past that specific point in the sky. The signal was there. It was as if someone had turned on a spotlight in the dark, held it steady as we passed by, and then clicked it off. But the real mystery of the WOW signal isn't what happened that night. It's what has happened every night since. In the 5 decades following that detection, astronomers have pointed the most powerful telescopes on Earth back at that same coordinate in Sagittarius thousands of times. They have used more sensitive equipment, broader frequency ranges, and sophisticated digital processing. The result has been a crushing, absolute silence. The signal has never repeated. It never moved. It never sent a follow-up message. Jerry Emmon himself eventually became one of the signal's biggest skeptics, suggesting it might have been a secret military broadcast or a reflection off a piece of space debris. Yet, no terrestrial explanation ever quite fit the data. A reflection would have moved. A military broadcast would likely have leaked into other frequencies. The WOW signal remained a ghost, a 72-second phantom that suggested we weren't alone, only to vanish before we could ask a second question. For nearly half a century, the WOW signal sat in a scientific limbo, neither proven to be alien nor explained away by nature. That changed on August 15, 2025, the 48th anniversary of the original detection. A team of researchers known as the Arecibo WOW team published a revolutionary analysis that finally provided a plausible, natural answer, and they did it by digging through the trash of history. They utilized a massive archive of previously unpublished data from the Ohio SETI project, much of which had been sitting in boxes for decades. This team didn't just look at the signal, they looked at the environment surrounding it. By using modern computational techniques to analyze over 75,000 pages of original data, they identified a phenomenon that the 1977 computers were simply too primitive to see. The 2025 breakthrough suggests that the WOW signal wasn't a message from an alien civilization, but a rare cosmic event involving a massive cloud of neutral hydrogen and a magnetar, an incredibly dense, highly magnetic star. The researchers hypothesized that a sudden, violent burst of energy from a magnetar passed through a dense cloud of hydrogen gas, causing the hydrogen atoms to glow brilliantly in the radio spectrum for a very short period. This process, known as stimulated emission, is essentially a natural cosmic laser. It would explain the incredible intensity of the signal, its narrow frequency at the hydrogen line, and most importantly, why it never happened again. Magnetars are notoriously unpredictable, and the alignment required for such a burst to pass through a specific cloud of gas and hit Earth at exactly the right moment is a 1 in a billion occurrence. This new explanation is a masterpiece of scientific detective work, but it carries a bittersweet weight for those who hoped the signal was a greeting. If the Arecibo team is correct, the WOW signal wasn't a hello, it was a cosmic fluke, a beautiful but meaningless flash of energy in the dark. Abel Mendes, one of the leading scientists on the project, noted that while this discovery solves a 50-year-old mystery, It also emphasizes how difficult it is to tell the difference between a natural glitch and a genuine message from the stars. It reminds us that the universe is full of loud, strange things that have nothing to do with life. We are living in an environment where a dying star can sound exactly like a radio transmitter, making our search for real intelligence even more of a needle in a haystack nightmare. The human story behind the data is perhaps even more tragic than the loss of the alien hypothesis. The Big Ear Telescope, the instrument that gave us the most significant hint of extraterrestrial life, no longer exists. In 1998, the land it sat on was sold to developers, and the telescope was demolished to make room for a golf course. The site where humanity arguably had its first brush with the infinite is now a manicured green where people spend their weekends putting for birdie. The only reason we even have the data to analyze today is because of the tireless work of volunteers. When the observatory was shut down, over 75,000 pages of computer printouts were saved from the dumpster by people who spent years photographing every single sheet, ensuring that the legacy of those 72 seconds wasn't lost to a landfill. This brings us back to the central tension of the Fermi Paradox. If the WOW signal was just a hydrogen cloud stimulated by a magnetar, then we are back to square zero. We are back to a universe that is perfectly, terrifyingly silent. Every time we think we've found a lead, every time we hear a rustle in the dark forest, it turns out to be the wind. We are 65 years into the search, and we have exactly 0 confirmed signals from another civilization. We have scanned billions of frequencies and monitored hundreds of billions of stars, and the only voice we have ever heard is our own. This sustained silence is starting to force a change in the scientific consensus. For a long time, the default assumption was that they must be out there. We assumed that because the numbers were so big, life must be everywhere. But as our technology has improved, as we move into 2026 with AI-powered arrays and gravitational wave detectors that should be able to hear a civilization across the galaxy, the lack of results is becoming a result in itself. The failure to find a signal isn't just a lack of data, it is becoming a data point that suggests a very different reality. We are beginning to face the possibility that the Great Silence isn't a mystery to be solved, but a fundamental truth about the universe. We are starting to realize that the reason we don't hear anyone isn't because we are looking in the wrong place, or because everyone is hiding, or because they all killed themselves. The reason might be much simpler and much more profound. It might be that in a galaxy of 400 billion suns, there is only one spark of consciousness. If the WOW signal was just a natural glitch, we have to stop asking where are they and start asking a much more terrifying question. What does it mean for the future of the galaxy if we are truly, completely alone? If there is no one else to hear the music? If there is no one else to see the stars? Then the weight of the entire universe falls squarely on our shoulders. We are no longer just one of many. We are the only ones left to bear witness to the cosmos. And that realization changes everything about how we see ourselves, our planet, and our responsibility to the future. If the WOW signal was nothing more than a natural glitch, a cosmic spark in a dead cloud of gas, then we are forced to stare directly into the most uncomfortable mirror in the history of science. We have to stop looking for them and start reckoning with us. For over half a century, the search for extraterrestrial intelligence was fueled by a kind of cosmic modesty. We didn't want to believe we were special. We assumed that in a universe this vast, with 400 billion stars in our galaxy alone, the idea of being the only intelligent species was a form of arrogant, pre-Copernican delusion. We wanted to be one of many. We wanted to be part of a crowded, noisy, vibrant galactic community. But as we move deeper into 2026, the data is beginning to tell a much loner story. The Great Silence isn't a technical failure of our telescopes. It is a profound biological and physical reality. We are likely standing in a house with 400 billion rooms, and we are the only ones who have ever turned on a light. The mathematical weight of this isolation was laid bare by the Future of Humanity Institute at Oxford. When researchers like Anders Sandberg and Toby Ord revisited the Drake equation, they didn't just plug in their favorite guesses. They looked at the entire range of scientific uncertainty across every variable. They realized that for decades, we had been averaging out our ignorance, which created a false sense of optimism. When they ran their models through millions of simulations, accounting for how little we truly know about the origin of life and the evolution of intelligence, the bell curve shifted violently toward the left. Their conclusion was a hammer blow to our cosmic ego. There is a 53 to 99.6% chance that we are the only technological civilization in the Milky Way galaxy. In the entire observable universe, that probability ranges from 39 to 85%. Think about those numbers for a moment. We aren't just saying that aliens are rare. We are saying that the most scientifically rigorous models we have today suggest that we are, in all likelihood, an absolute anomaly. We are a one-off event in a universe that has existed for 13.8 billion years. This realization transforms the Fermi Paradox from a fun intellectual puzzle into a staggering existential burden. If the Oxford study is correct, then every single star you see in the night sky, all 400 billion of them in our local neighborhood, is a silent, empty furnace, providing warmth to dead rocks that will never host a thought, a dream, or a single word of poetry. This brings us to the 10 billion trillion paradox. In 2016, astronomers Adam Frank and Woodruff Sullivan attempted to calculate the pessimism line. They asked exactly how unlikely does the development of a technological species have to be for us to be the only one that has ever existed in the history of the observable universe. They calculated that for us to be unique among the 2 trillion galaxies and 10 billion trillion stars in the cosmos, the probability of a civilization forming on a habitable planet would have to be less than 1 in 10 billion trillion. On the surface, that number sounds so small that it seems impossible. It feels like a safe bet that someone else must have made it. But when we look at the 4 billion year chain of impossibilities that led to humanity, the freak accident of the complex cell, the billion-year stability of our climate, the protective gravity of Jupiter, the rare existence of plate tectonics, and the bizarre environmental pressures that forced a group of primates to develop massive, energy-hungry brains, that 1 in 10 billion trillion shot starts to look like a realistic description of our history. We are the survivors of a lottery where the odds of winning were effectively zero. Yet here we are, holding the ticket and wondering why no one else is in the winner's circle. If we are truly alone, it changes the very definition of what the universe is. Without consciousness, the universe is just a vast, cold machine. It is a series of chemical reactions, gravitational collapses, and nuclear fusions. It is physics without purpose. Stars explode, galaxies collide, and black holes evaporate, but there is no one there to see it, to name it, or to find it beautiful. In a universe without life, there is no such thing as tragedy or glory. There is only the movement of matter. We are the meaning makers of the Milky Way. We are the only part of the universe that has woken up and started asking questions about where it came from. Brian Cox touched on this profound responsibility during his introduction to the COP26 climate summit. He suggested that if we assume we are currently the only civilization in the Milky Way, then Earth is the only island of meaning in a sea of 400 billion suns. This isn't just a poetic sentiment. It is a terrifying political and moral reality. If we allow our civilization to collapse, whether through nuclear war, environmental destruction, or the reckless development of unaligned technology. We aren't just ending the story of a single species. We are potentially extinguishing the only light of consciousness in an entire galaxy. Perhaps forever. The weight of this existence is almost too much for a single species to bear. We have only existed in our modern form for about 200,000 years. We have only been capable of listening to the stars for about 65 years. In the grand timeline of the cosmos, we are a flickering candle that has just been lit in a massive, dark cathedral. The Great Silence tells us that no one else has ever managed to keep their candle burning long enough to light up the room. Every other attempt at intelligence, if there were any, has been snuffed out by the Great Filter before they could reach out and touch another world. This makes every decision we make today, every policy, every invention, every act of war or peace, a matter of galactic significance. We cannot afford the luxury of being human in the traditional sense of being tribal, short-sighted, and violent. If we are the only ones left, we have to become the guardians of the very concept of intelligence. We have to be the civilization that finally beats the odds, that survives the technological adolescence that has likely claimed every other world in the dark forest. The Fermi Paradox, in the end, isn't about aliens. It's a mirror that reflects the extreme fragility and the extreme value of human life. The Ha Dang Erdo. Where are they? Question of Enrico Fermi has been answered with a haunting, "It's just you." And while that answer brings a deep sense of loneliness, it also brings a radical kind of hope. If there is no one else to save us, no galactic federation to intervene, and no ancient precursors to guide us, then we are the masters of our own destiny. The future of the Milky Way is not written in the stars. It is being written right now, in our laboratories, in our parliaments, and in the way we choose to treat one another on this pale blue dot. We are standing on the edge of the ninth door, the door to becoming a multiplanetary, interstellar species. The silence of the universe suggests that this is the door that almost no one ever opens. It is the final filter. But the fact that we are even standing in front of it, armed with the data of 2026 and a growing understanding of our own precariousness, means we have a chance. We are the only ones who can turn the great silence into a great beginning. The universe is a dark forest, and for now, we are the only ones shouting. But perhaps the goal isn't to wait for a reply. Perhaps the goal is to grow so bright, to become so wise, and to spread so far that the forest is no longer dark. If we are truly alone, then we aren't just the observers of the cosmos. We are its future. We are the reason it exists. And that is a responsibility we cannot afford to fail. The stars are waiting, and for the first time in 10 billion years, someone is finally looking back.